In this video, we'll be solving equations with cube and cube roots. When we solve equations, we use inverse operations and find the value of the variable that makes the equation true. Cube and cube roots are inverse operations. So for example, knowing that the cube means multiplying the number by itself 3 times, 2 times 2 times 2, is 2 to the third power, which is 2 cubed. The value is 8. The inverse operation will be the cube root. So cubic root of 8 can be written as cubic root of 2 cubed, which is same as 8, but then cubic root and cube are inverse operations. They cancel each other, therefore the value will be 2. So the cubic root of 8 is 2. Why? Because 2 times 2 times 2 is 8. Cube root of 8 is 2. Let's look at another example. 4 times 4 times 4, multiplying the base by itself 3 times, is called cube, 4 to the third power, which is 64. The inverse operation will be called cubic root. Cubic root, the little 3, is telling you that 64 is the answer for multiplying something times something times something 3 times. That number is 4. Cubic root of 4 to the third power, because 4 times 4 times 4 is 64. So I can write as inverse operation that cube root of 64 is cube root of 4 to the third power, and show that cube and cube root are inverse operations. Therefore, the value of cube root of 64 is 4. Same goes for negatives. Negative 3 times negative 3 times negative 3 is the base multiplied by itself 3 times. So negative 3 to the third power is negative 3 cubed, which is negative 27. The inverse operation is cube root of negative 27, where I can write the negative 27 as negative 3 to the third power and show that cube root and cube are inverse operations. So the value of cube root of negative 27 is negative 3. Why? Because negative 3 times negative 3 times negative 3 is negative 3 cubed, which is negative 27. Negative times negative times negative is still negative, because negative times negative is positive, and then times another negative is negative. So the base multiplied by itself 3 times is the base negative 5 to the third power, which again, negative times negative times negative is negative 125. The inverse operation, cube root of negative 125, can be written as cube root of negative 5 to the third power, and then we show that cube root and cube are inverse operations. So therefore, the cube root of negative 125 equals negative 5. Why? Because negative 5 times negative 5 times negative 5 equals negative 125. Same goes for variables. X times x times x equals x to the third power. Or y times y times y will be y to the third power. Or any variable multiplied by itself 3 times will be that variable, keep the base to the third power. The inverse operation will be cubic root of x cubed. Cube and cube will cancel each other, so the value will be x. Cubic root of x cubed will equal x. So we're going to have a few equations for us to solve, and if you would pause the video and copy the chart first, that would be helpful. So we have the equation. We'll use inverse operations to solve the equation, and then we'll check the solution. First equation, x to the third power equals 8. Let's see how to solve that one. The meaning of the equation is what number multiplied by itself 3 times equals 8. In other words, what number times what number times what number, and they're all of the same kind, will equal 8. 2 times 2 times 2 is 8. So we say 2 times 2 times 2 equals 8. That means that the x value equals 2. So my solution should be x equals 2. Now I'm going to take the same equation and show how to use inverse operations to solve. So the equation is x to the third power equals 8. The inverse operation of cube is cube root. So what we're going to do is use cube root on both sides. Once we do something in the equation, we have to do the same thing on both sides to keep the balance. So on one side of the equation, I had the x cubed. On the other side, I had the 8. Cube root and cube cancel each other, so that x value will be alone, and then the cubic root of 8 is 2. Why? Because 2 times 2 times 2 is 8. So here's when we check that solution. In the original equation, x to the third power, I'm going to put 2 to the third power equals 8. So to check your solution, you substitute in the original equation. That was your x value. In solution being 2, we substitute, and then we need to make sure we get the equality. 2 to the third power means 2 times 2 times 2. And then 2 times 2 is 4. 4 times 2 is 8. Your solution makes a true statement in the given equation, so that makes it true. Second equation, y to the third power equals negative 1. The meaning of the question is, which number multiplied by itself 3 times will equal negative 1? Negative 1 times negative 1 times negative 1. Negative times negative is positive, and another negative will make it still negative, and that will be 1. So each y value has to equal negative 1. Why? Because negative 1 times negative 1 times negative 1 is negative 1. Let's show using inverse operations for the same equation. Y to the third power equal negative 1. Cube and cube root are inverse operations, so we use the cube root on both sides. On one side of the equation I had the y cube, on the other side I had negative 1, but we use the cube root on both sides. So this is the inverse operation we're using of the equation that was given originally. Cube and cube root are inverse operations. Y will equal cubic root of negative 1, which is negative 1, because negative 1 times negative 1 times negative 1 is negative 1. So we can check that value by substituting in the original equation, and instead of y, we use negative 1 to the third power, and we want to make sure we get negative 1 after we check. So we have the third power means negative 1 multiplied by negative 1 multiplied by negative 1, where negative times negative is positive 1, and times the other negative is negative 1. So the solution being replaced in the original equation makes a true statement. Let's see an example with a fraction. We have t to the third power equals 1 over 64. So that means which number multiplied by itself, or which fraction multiplied by itself in this situation, will equal 1 over 64. Well, we know that 4 times 4 times 4 is 64, and then 1 times 1 times 1 is 1. So we can multiply 1/4 times 1/4 times 1/4 to get 1 over 64, because 1 times 1 times 1 is still 1, and 4 times 4 is 16, times 4 equals 64. So the t value has to be 1/4. the same equation, t to the third power equals 1 over 64. We're going to use inverse operations to solve. Cube and cubic root are inverse operations, so I'm going to use the cubic root on both sides. The cubic root of t cubed and the cubic root of 1 over 64. So the cubic root on both sides, cubic root of t cubed and cubic root of 1 over 64. Cubic root and cube are inverse operations, and we have t equal 1 times 1 times 1, so the cubic root of 1 is 1, and then the cubic root of 64 is 4, because 4 times 4 times 4 is 64. So our t value is 1/4. To check, in the original equation we have 1/4 to the third power should equal 1 over 64. So in the original equation, instead of the variable t, I substitute the value of t, which is 1/4, and then multiply it by itself 3 times. So 1/4 times 1/4 times 1/4 should equal 1 over 64. 1 times 1 times 1 is 1. 4 times 4 is 16. 16 times 4 is 64, which is the same value on the right side, which makes the equation true. We'll continue on the next page with the equation that has the cubic root equal a value, and see how to use the inverse operation and check that solution. Pause the video to make a chart, and then we'll move on. So example number 4. I have a cubic root of what number equals 3? Cubic root of what number equals 3? That means I have to figure out the inverse. So 3 times 3 times 3 is 27. Cubic root of 27 equals 3. So the x value must be 27, because this is my x right here. This is the x value. So that x value should be 27, because 3 times 3 times 3 is 27. The best resource for this solving equations, you have where we had on page 11 cube and cube roots, and we had all the cubes up to 15, and then the cubic roots on the number line. So you have this resource page that you can always refer back to and use your cube and cubic roots. So to use the inverse operation, just like we previously stated, if you have a cube in the equation, we're going to use, if you have a cube root in the equation, we're going to use the cube. So we have cube root of x equals 3. This is the original equation. Inverse operation is cube, third power. So we need to do the third power of each side. Third power of each side. In other words, use the inverse operation of cubic root, which is cube or third power. Here we have cubic root of x, and here we have 3, just the original equation. Cube and cubic root cancel each other, so x will be, here we have 3 to the third power, which means 3 times 3 times 3, and the x value equals 27. To check, plug in instead of x the value of 27, and that must equal 3. 27 is 3 times 3 times 3, so I can write that as 3 cubed. Cubic root of 3 cubed is 3, or cubic root of 27 is 3, which makes a true statement by being plugged in the original equation. Example number 5. Cubic root of what number equals -5? So think backwards immediately. 5 times 5 times 5 is 125, but you have negative 5. So negative 5 times negative 5 is 25, and times a negative 25 one more time, that will be negative 125. So we have cubic root of negative 125. This is your variable a, so that means a should equal negative 125. Now, in the equation, we have cubic root of a variable equals negative 5. The inverse operation of cube root is cube, or third power. So we have to use the cube on both sides. The inverse operation used on both sides of the original equation. So we have cubic root of a, and we have negative 5 on the right. Cube and cube root are inverse operations. A value will be negative 5 to the third power, which is negative 5 times negative 5 times negative 5, where negative 5 times negative 5 is positive 25, and times another negative 5 is negative 125. That is your a value. The value of a we can check in the original equation by plugging instead of a negative 125. The value of the variable must make the equation true. So we have cubic root of negative 5 cube, because negative times negative times negative is negative. 5 times 5 times 5 is 125. Cube root and cube cancel each other, so negative 5 on both sides create the balance, which makes the equation true. Let's see one equation with fraction. We have 2/3 equals cubic root of n, so we want to think backwards, or the inverse operation. 2 times 2 times 2 will be 8. 3 times 3 times 3 will be 27. So the 2/3 fraction multiplied by itself 3 times will be the value of the variable n under the cubic root 8/27, because 2 times 2 times 2 is 8, and 3 times 3 times 3 is 27. And this is your variable n, 8/27. How to use inverse operations to solve. So we have 2/3 on one side, cubic root of n on the other. If you have a cube root in the equation, we need to use cube on each side, using inverse operations to solve. On the one side of the equation we have 2/3, on the other we have cube root of n, where cube and cube root cancel each other, so n variable will be 2/3 times 2/3 times 2/3, which is 2 times 2 times 2, 8, and 3 times 3 times 3, 27. Check by plugging in the 8/27 in the original equation. So 2/3 must equal the cubic root of 8/27. By plugging in the n value in the original equation, cubic root of 8 is 2, and cubic root of 27 is 3. That makes a true statement in the equation. The next two equations are one of each kind. Would you copy them in your notes, please? And then we are going to discuss them in class after you give it a try.